Hi, I'm Paul Brodie. Welcome back. So, what's been going on? Well, I had a birthday. Can you believe that I'm 71 years old? Still working in my shop, still making YouTube videos. I know. Thanks for watching. So, we're going to do Aramaki today. It's the big bore. I got the head back. The valve seats are all cut. The intake port is opened up a little bit. So that's what it looks like. And this is a stock head over here. So I'll pull the valves out of this one and you can make a little bit of a comparison. Can you see how, maybe it's a little hard to see, but this is larger. Here's the valve sizes, for example. You can see the intake's larger and the exhaust is also larger. Now, last time we worked on this, I was machining out the head and something moved a bit, because if you look at the valve seat, can you see how there's a lot of extra here, and over here there's no extra really, but it's okay. It worked out okay. Just means that when I was machining it, I didn't hold it really securely and something moved. So that was me. So what we're going to do today is to open up this here for the larger liner. So here's the two liners. This is the new one. This is the stock one. And can you see how it's bigger? The one on my left is larger, so that has to go into here. What that means is we're going to hold it in the mill on the rotary table. This is the fixture I made up many years ago, and it's going to hold the head so that it turns around. And then we're going to open up that, and we're going to face this a little bit to raise the compression. And then because we're raising the compression and taking this surface down, we also have to cut this surface down as well, because you have to maintain that height there. So I got a new end mill, and it's carbide. After sales tax, better not drop this. That was $117. And carbide is really strong. So this one's a little smaller. This one is HSS, high-speed steel. There's a marking somewhere on it. There it is, HSS. So I thought it'd be interesting if we weigh these. I got my weigh scale here. So this is the longer one, and it's 118.7 grams. This one is shorter. Can you see that? And it's 213.6 grams. So even though it's smaller, definitely weighs more, because this is some pretty solid stuff. It should last a lot longer if I don't drop it. The worst thing I do on these things is that I got it in the mill, I open up the collet, and it falls on the table, and it breaks off one of the tips. So I'm going to be very careful with this. Have a piece of wood underneath, so if it does fall, it doesn't end up on the table. Okay. Something else I've worked on is the rocker arms. This is a stock one. I think it's a forging. I don't think it's a casting. And what I've done here, I've machined it down. I think I showed you in a video where I hold this in the lathe. There's my holder. And I put it on one side first. Hold it, and I machine down, and then I flip it around, and I machine down, and then I do some filing. So I've done some filing and sanding on this one. I still have to do the final sanding. I've saved about an ounce of weight, so not that the bike will go any faster, but it's just for my own satisfaction, I believe. That's why I do these things. Okay, so that's basically what's going on. Oh, someone asked a question. When I think the last time I was showing this, and you see how this is larger than that? Because this is a larger bore, 5 millimeters larger. And you see how this fits in like that? There's a little bit of a gap there. Maybe I'm estimating 5 thou, 4 thou, something like that. And one of the viewers asked a question, and he says, why don't you just put this in the lathe and make this smaller? And that's a good question. And the reason that I don't want to do that is because it's the surface area. There's no head gasket. This just goes straight onto the head. And the less surface area you have, it's not as good. It's always good to have more surface area. So that's why we're going to open up this and make this fit into there. That's our job for today. I took a spark plug and I cut it down and I welded in this. Been a long time since I used this. Okay. And there's a flat spot. The flat spot goes wherever it wants to hit. Somewhere there. This time I'll make sure everything is nice and tight, because that was not a good thing when I did the valve seat and things loosened up. It's not easy doing something while the camera is rolling, let me tell you. It's not so simple. Okay, so that's good. Allen screws here hold it down, and then the spark plug insert holds this. So okay, can you see how that's tightening up? Okay. All right, so this goes in the chuck, on the rotary table, on the mill. Gets hold. We got to dial it up a little bit to see what's happening. I don't want it to be a lot off, so let's go to the mill and see what's happening. Thanks for tuning in. Okay, it's just touching. And I'm going to go back this way. $116. So it's a little bit too small still, so I'm going to take off a little bit more metal. I'm also going to raise up the head so I can do the surface where what is the head gasket. because I can see that it's hitting on one side and not hitting on the other side, so needs a little bit. Okay. Oh, look at that. Turned out pretty nice. It's probably about, I'll actually measure it. Should be about, I'm guessing, 6 or 8 thou over. And it is 7.5 thou over. So it's got about 7 thou clearance on the muff. And what we have to do now is to take a little cut off the top here. Can you see how this is raised up a little bit? But just to make it even. Long dials. Well, that was a successful operation. No hiccups, didn't break a tool or damage anything. No AI was used in this video whatsoever. I want you to know that. Thank you for watching. We appreciate your support. Please buy us coffee. It really does help a lot. Like, subscribe, tell your friends. See you next time. Stay safe.